Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see RF receivers in this particular video. We're going to see tuned RF frequency receiver and amplifier sequenced hybrid receiver in this particular video, right? We already seen RF transmitters, and this is all about RF receivers. When it comes to RF receivers, we have a lot of receivers, that is TRF receivers, AHF receivers, super heterodyne receivers. Like that, you have a lot of receivers, and today we're going to see about TRF receiver and ASH receiver, right? To start with, if you take any particular receiver, this is the simple TRF receiver. Not only TRF receiver, if you take any particular receiver, the main operation is it has to receive the signal which is transmitted, and from the received signal it has to reconstruct its original data. That is the normal operation, right? Say for example, if you take this TRF receiver, you can see the antenna here that will receive the signal, and then that signal will be amplified. If it is weaker signal, it will be amplified, and then very important concept is down conversion in the receiver. Down conversion. So what is down conversion? We know that in the transmitting side, we would have amplified the signal and we would have transmitted using the antenna. And at the receiving side, what we have to do is we have to first convert that high frequency signal to an intermediate signal so that we can process that particular signal and we can detect the original data that is transmitted, right? So that is very important step, which is called as down conversion, right? Which is done in almost all receiver, so that you will use a mixer. What is mixer? It will mix this RF signal and the local oscillator signal so that the original signal frequency will be down converted to an intermediate frequency, right? Which is a frequency which is below the RF frequency, right? So what we will obtain is we will obtain an IF frequency, and that IF signal can be amplified, and from that IF signal, you can see here, from that IF signal, it has been sent to the detector where it performs the detection process. It will detect the original message component. Say for example, if it is an audio component, we will detect the original component, and if needed, we can amplify that, right? So this is the common operation for almost all receivers, right? And when it say receivers plays a very vital role to determine the performance of the wireless links, right? And very important concepts in receivers are down conversion, because only after down conversion we can able to process that particular signal, and from that signal we can able to detect the original signal which is transmitted, right? And in most of the short range receivers, we will use super heterodyne receiver, but apart from super heterodyne receiver, there are a lot of other receivers like TRF receiver, ASH receiver, right? And direct conversion receiver, right? Super heterodyne receivers, like that. You have a lot of receivers, right? And very important requirement for the short range receivers is its simple design, size and cost, right? And I've already explained what is down conversion, and whenever it comes to receiver, two important parameters is very important, that is selectivity and sensitivity. So what is selectivity? Selectivity is the ability of the receiver to select the correct signal from various signal. That is called as selectivity. That is, we can also put it in other words, the receiver is capable of receiving the signal which is transmitted from the transmitting side. That signal, right, for example, even in transmitter side you will be using an oscillator, so definitely you will have an undesired signals along with the desired signal. You will have a lot of noise signals, right? So the receiver should be very clever in order to receive the correct signal. It has to select the desired frequency signal, the desired signal that is transmitted, apart from the noise and all those things, right? So the ability of the receiver to reject all other signal and select the exact signal, exact desired signal, that is called as selectivity. And what is sensitivity? The ability of the receiver to amplify this selected weak signal, that is called as sensitivity, right? So even if the desired signal is very weak, the receiver has to select that particular signal exactly. That is called as selectivity, and that selected signal has to be amplified to a like the desired weaker signal has to be amplified. That is called as sensitivity. So you can see here, selectivity is ability of a radio receiver to reject the signal which is close to the desired frequency, and sensitivity of a receiver is its ability to amplify the desired weak signal. That is called as sensitivity, right? And coming to tuned radio frequency receiver, right? As I said, if you take any particular frequency receivers, RF receivers, you will have these elements. That is, you will have a BTF, RF amplifiers, and then you will have a detector, right? And depending upon the application, you will use comparator or amplifiers, audio amplifiers, like that, right? Here in tuned radio frequency receiver, first what we will do is we will receive the signal, right? Using the antenna, we will receive the signal, and now this signal which is received is an RF signal, right? This is an RF signal. The first part is we have to make this RF signal to tuned to the desired frequency. That is, we know that is the receiver has to be tuned to a particular frequency, right? It has to receive a signal only for a particular frequency range, right? So first what we will have is we will have a tuning circuit which will tune this frequency which is received. It will tune this particular signal to the required RF signal, to the required RF frequency signal, right? So it will tune that particular signal so that it will eliminate all other signals, and it will tune that RF signal which is received. That is, it will allow only a certain frequency of signal, right? So that we can able to detect the original message signal that has been transmitted, right? So the first part is tuning circuit, where you have a tuning circuit. The tuning circuit will have inductor and as well as capacitors, right? Or else we can also use band pass filters which will allow certain range of frequencies, right? And once it is done, that signal which has been tuned is sent to the RF amplifiers. When it comes to RF amplifiers, we will use different stages of RF amplifiers. We can have multi stages of amplifiers. We have used two stages here. We can use multi-stage of RF amplifiers where it will amplify the signal which is received from the tuned circuit, right? And once it is amplified, right, and it is sent to the detector, what detector will do here, it will find out the original signal that is transmitted. That is, say for example, if you used a modulator on the transmitting side, which will combine the message signal and the carrier signal, whereas the detector, what here it will do is it will segregate the message signal and the carrier signal, and it will remove the carrier signal, and it will extract only the original message signal, and we can able to detect the original signal that is transmitted here, right? Here we can directly use the signal which is received, which is detector, or we can send that to a comparator. Say for example, we need to reconstruct a digital baseband signal, then this signal can be sent to the comparator to reconstruct the digital signal, right? Or else if it is an analog signal, where we can also use an audio amplifier where it will amplify that particular signal so that we can able to hear it louder, right? So this is the working of TRF receiver, tuned radio frequency receiver. We are receiving the signal, we are tuning it to a particular frequency, and then we are amplifying that signal, and from that we are converting it, right? So this is the working of TRF receiver, where you can see we have used band pass filter, right? A band pass filter, it will tune to the required frequency, right? And you can see the signal is amplified, and by using RF stages, and then it is sent to the detector where demodulated, it will detect the original signal that is transmitted, and if needed we can use comparator where the digital baseband signal can be reconstructed, right? And very important thing here is we are using RF amplifiers, right? We know that RF amplifiers have high voltage gain, right? High gain will be there, so the gain of the RF amplifiers has to be limited here, right? So there is a restriction for the gain of the amplifier, because if the gain is more, then what will happen is it will create oscillation. It will create oscillations, right? Whereas what we have done is, if it creates oscillation, it will create interference with the signal which is received, right? So that is why the gain here is very limited. because too much of gain will result in a positive feedback where it will create a random oscillation which will affect, which will create noise or interference with the transmitted signal, that is received signal, right? So the gain is restricted here, and the very important advantage of TRF receiver is we are not using any local oscillators here, and that is why even the gain is also restricted here, because it does not create any oscillations. Okay, right? We does not use any local oscillator here or any radiating source, so that no interference is present here, no interference will be created, right? And very importantly, it is used for short range devices, and it does not require any FCC or European regulations, right? We don't need any regulations that is permission or approval from these FCC regulations or European regulations, right? And this is about tuned radio frequency receivers. And very importantly, when we say tuned radio frequency receivers, as I said, it is used in short range devices, especially we can use it for even a wireless mouse, right? But this TRF receiver, we have different version of it. The another version of TRF receiver, we call it as a clever version of TRF receiver, which is ASH receiver, amplifier sequenced hybrid receiver, amplifier sequenced hybrid receiver. Whereas the operation, everything is same, but the only difference is instead of using band pass filter, what we use is we use a SAW filter. SAW is another type of a band pass filter where it is a surface acoustic wave filter, right? By using this filter, what we can do is we can able to achieve higher selectivity in the ASHF receiver, right? The selectivity of the AS receiver is determined by this, predominantly determined by this SAW filter and by this SAW line, right? And in this particular ASH receiver, we have two separate gain stages. That is, we have two separate amplifier stages. That is, you can see here, this is stage 1 and this is stage 2, right? But here also we are limiting the gain to avoid the positive feedback, right? That is because in order to suppress the unwanted oscillations. But here, the signal which has been received, right, it has been fine-tuned by SAW filter, and then it is sent to the first stage amplifier, where the signal will be amplified here, and then it will go to the second stage where it will be further amplified. So there will be a increase in gain. The total effective gain will be the sum of this gain at these two stages, right? That is only difference in ASH receiver, right? And coming to the working of AS receiver, as I said, we have two amplifier stage, two gain stage here, and these two gain stages designed in such a way that it will be switched at different conditions, at different situations, right? We have a switcher here. You can see here, when this is turned on, right, this will be turned off. When second stage is turned on, this will be turned off, right? And for this, we are using a SAW delay line. That is because whenever a signal is received from this SAW filter, this amplifier will amplify the signal. That signal, the amplified signal, has to be sent to the SAW delay line, because the signal which is amplified here, right? This has to be turned on, right, until this is turned off, right? It will be turned off condition, right? And this will be turned on only if this goes turned off, right? So once the signal is created, that is, once the signal is amplified here, that signal has to be holded for a certain amount of time, so that this will become turned off and this stage will become turned on, so that we can send that particular signal to this particular amplifier, right? So for that, we are using a SAW delay line, where this will create 0.5 microseconds of delay line, whereas it can also be acting as a storage element, where it will hold this particular amplified version of the signal for a 0.5 microseconds, so that then it will be turned on. The second stage amplifier will be turned on, and it will further amplify that particular signal. And then it is a normal process of detection and comparator working, right? It's the same TRH receiver. The only operation here is we are using SAW filter and we are using SAW delay line along with two gain stages, right? So the working here, it will be, the signal will be received from the antenna, and then it is sent to the SAW filter where it will be fine-tuned to the correct frequency, and then it processed to the two gain stages as I said, and then it is sent to the detector where we will receive the original signal. We will detect the original signal, and that signal can be used as it is, or it can be used to if it is digital signal is required, we can send it to the comparator so that we can able to reconstruct the baseband digital data, or else we can use an audio amplifier in case of analog signal to amplify the signal which is detected, right? So this is the working of ASH receiver, right? And when it comes to ASH receiver, like as I said, TRF receiver is good for wireless communication for very short range devices, right? For example, wireless mouse, and predominantly it is considered for ASK modulation, amplitude shift keying. Both this TRF and AS receiver requires like it consumes only low power, so that it can be used in battery operated transceivers. So this is the power consumption, that is, it requires only 3 to 5 milliampere of current, right? And the average supply current can also be reduced for this particular receiver because they have this low current sleep mode and periodic wake ups to check up if there is a signal is received or not. So this particular option of going to current sleep mode, that is low current sleep mode, will further reduce the average supply current that is required, right? So this is the greatest advantage of this ASH receiver, right? And this ASH receiver, it has higher selectivity than the TRF receiver, as I said, and we can also improve this ASH receiver for a longer range, right? Not only for short range devices, we can make it for a longer range if we can able to improve this sensitivity of this ASH receiver, right? The sensitivity must be equal to super-entertainment receiver, right, or regenerative receiver, something like that, so that it can cover for a longer distance, right? So today what we have seen is we have seen an important concept in short-range wireless communication. We have seen what is TRF receiver and ASH receiver. I believe this video will be very useful for you. Thank you, my dear students.